The traditional software development stack is being restructured around AI capabilities. Previously, there was a concept of being a T-shaped engineer, where you would specialize in a specific skill and then branch out into other areas. I.e., maybe you would learn about back-end development and build out APIs, but you'd also know how to do some basic things around front-end design, creating a web page, how continuous integration and continuous delivery works, etc. But where does AI fit into this tech stack? And what does that mean for how we build software? Well, that's the topic on today's Tech Thaumaturge. For decades, the tech stack had been relatively stable layers: database, back-end, front-end, infrastructure. Those roles and tools were defined around these layers completely. AI is disrupting this structure, not just adding a feature, but changing how software gets built at every one of those layers. Here's a brief foundation for my non-technical viewers. A tech stack is the combination of technologies used to build and run an application. Traditional layers usually are infrastructure, servers, cloud, database for storing data, backend for business logic, and front-end, or the user interface, what you see, and then DevOps, deployment and operations. These layers make up pretty much everything in software. Each layer has specialized tools and skills. That's changing dramatically right now. AI integrates across the entire stack. It's not just a new layer. AI doesn't just sit on the top, it weaves throughout everything. How AI appears in development? Well, it writes code at every layer. In the product, AI powers features users interact with. This is common and it's ubiquitous. In operations, AI monitors, diagnoses, and optimizes. In testing, AI generates and runs tests. AI is horizontal across the stack, not a vertical addition to the stack. AI as infrastructure versus AI as feature. Well, there's two distinct integration patterns. You've got AI as infrastructure. The development process itself uses AI. Coding assistance, automation, testing, deployment optimization. Users don't see all of this though because it's behind the scenes. The other side is AI as a feature. The product includes AI capabilities, chatbots, recommendations, content generation. Users directly experience this. Think stuff you use AI for when you use it. Most projects use both. AI helps build the software, the infrastructure, and appears in what users see, the feature, on the front end. Distinguishing these helps clarify how AI fits your work. Let's talk about some of these emerging patterns. Here's what we're seeing in modern development. AI-first development, starting with AI capabilities as a core, building around them. Next, you have AI-assisted development, using AI to accelerate traditional development approaches. Next, you have hybrid approaches. AI handles what it does well, and humans handle what requires judgment. MCP and tool integration. AI assistants connected to development tools and AI APIs directly. Now, these patterns are evolving rapidly. What's experimental today quickly becomes the standard tomorrow. This will probably change by the time I upload it, if I'm being honest. This is changing so quick every day. Let's talk about the changes to traditional roles. Roles are shifting, they're not disappearing. In regards to back-end development, it's more about orchestrating AI capabilities and less about writing routine logic. In regards to front-end development, AI can generate UI code quickly. Emphasis shifts to better overall design and UX decisions. DevOps, or Dev Operations, more AI-powered automation, human focus on architecture and edge cases. Database work, AI helps with query optimization and schema design. Humans focus on data strategy. The skills needed at each of those layers are changing. Technical skills blend with AI collaboration skills. What developers should learn? Well, practical guidance for technical people. Let's first get into universal. Effective AI collaboration, prompt engineering and iteration, output verification and quality judgment, and when to trust versus verify AI. It is wrong frequently, and you need to understand them. Layer specific, understanding your domain deeply. AI assists better with your domain knowledge if you know it deeply. Architectural decisions. AI can implement, but humans should architect. Integration patterns, connecting AI capabilities with traditional systems. The most important skill is learning how to learn. The stack will continue to change every day. If you know how to learn and you want to learn, you will get better at this. So what should teams learn? Well, for the organizational adaptation, team-level changes are workflows that incorporate AI, review processes for AI-generated code, quality standards that account for AI assistance, and knowledge sharing about what actually works and what doesn't, for that matter. What about process changes? Fast iteration cycles, different code review dynamics, new testing approaches, updated documentation practices. AI changes how teams work, not just how individuals work. This is important, and it's something you're going to have to understand, especially in this industry. But not everything is changing all at once. Things that are relatively stable include fundamental computer science concepts, architectural principles, security fundamentals, database theory, things like that. So here's what's rapidly changing: specific tools and frameworks, development workflows, AI capabilities themselves, and integration patterns. You want to invest in fundamentals that stay relevant. Stay flexible on tools that evolve. So where is this heading? To be honest, no one really knows. We all have best guesses. I can tell you though, from my experience, more AI integration at every layer is probably going to be the norm. There's going to be a lower barrier to entry for software development and a higher ceiling for what skilled developers can accomplish. There's going to be a lot more blurring lines between traditional roles. Here's what persists: a need for judgment and architecture, security and reliability requirements, domain expertise value, and human accountability for systems. AI doesn't eliminate the need for developers, it changes what they do. Let's talk about some practical application. Let's map it to your current stack. Where does AI already appear? Identify integration opportunities. Where could AI help at each of the layers where you work? Invest in transferable skills, architecture, judgment, domain knowledge, things like that. Stay flexible on tools. They will keep changing every day. Experiment actively. Hands-on experience beats theory any day, especially as AI keeps evolving. The tech stack is being restructured around AI, not as a new layer, but as a capability that weaves through everything. AI appears as infrastructure, helping build software, and as a feature in the product itself. Roles are evolving, not disappearing. Invest in fundamentals and judgment. Stay flexible on tools and workflows. The stack will keep changing. Adaptability is the most valuable skill.